Good morning, dear students. My name is Ferhan Mazher, and today is 31st of March 2021. And right now, I am with you, and the subject we are studying is Physics 5054. It's O levels physics. And today we have set our heart to solve MCQ paper, and this MCQ paper is May June 2014 1-1. This paper belongs with from the zone 1, variant 1. So let's start May June 2014 and 1-1 paper, MCQ paper. Let's start this paper. So the first question coming on your screen is a workman measures as accurately as possible the length and internal diameter of a straight copper pipe. The length is approximately 600 centimeter and the internal diameter is approximately 2 centimeter. What is the best combination of instruments for the workman to use? Okay, so the length is approximately 600 centimeters, approximately 6 meter. So we will definitely use a tape, and the internal diameter is approximately 2 centimeter. You know that the vernier caliper, it has jaws, internal jaws with the which it can measure the internal diameter of anything. So for the length you will use a tape, and for the internal diameter we will use the vernier caliper. So question number one, internal diameter vernier caliper, and for the length we will use the tape. So D is the right option. The diagram shows a stopwatch. What is the reading on the stopwatch? So you can see there, here we have a stopwatch. So 30, 31, 32, 33, 34, 35, 36. So the reading is 36 seconds. It's measuring in seconds. This is written here, seconds. So C is the choice. Question number 2, C is the choice. The graph shows how the speed of a car traveling in a straight line changes with time. Which section shows the largest acceleration? You see, it's a speed time graph, and the largest acceleration will be where the gradient of the graph is largest, where the graph is steepest. So by the looking at these lines, so you see this line has the greatest or steepest gradient. So question number 3, A is the choice. An object falls from rest through the air and the air resistance on it increases. So air resistance is present. The object reaches terminal velocity, which quantity decreases until its terminal velocity reaches. You see, try to understand this thing. Whenever the air is present and you drop an object, and what will happen? Its velocity at the start will be 0 and the velocity will gradually increase. At the start, the acceleration will be, especially on Earth, the acceleration will be 10. But as the air resistance will increase, the resultant force will decrease. So the value of the acceleration will decrease. Let's say at the start, it will be 10 meter per second square. In the next moment, it might be 9, then it will be 8, then it will be 7. So when the air resistance and the weight and the air resistance, they will become equal, the A value, acceleration value will become 0. So as the the object falls, the velocity is increasing. So it means, but the acceleration will be decreasing. At the start, it has the maximum acceleration, and gradually the acceleration decreases. His question is which quantity decreases until its terminal velocity reach, that is acceleration. So the answer is A. Kinetic energy is not decreasing because its speed is increasing. So the kinetic energy depends upon the speed. So the kinetic energy will increase. Speed is increasing. Weight do not change during the fall. So A is the choice. A man pushes a heavy box along the ground. A force acts between man's hand and the box. Another force acts between the man's feet and the floor. In which direction do these forces act on the man? You see the man with his hands applied force on the box towards right. So the box will apply force on the hands towards left. So the force on the man's hand will be towards left. With his feet he's trying to push the earth backward. So the earth, I mean towards left, is with his feet he's applying force on the earth towards left. So the earth will apply force on his feet towards right. So B is the best option. So B is the best option. Question number 5, B is the best option. So the next question on your screen: in which situation is the resultant force on the body equals to zero? Resultant force on the body will be equals to zero if all the forces are balanced. A car turning a corner at a constant speed, whenever you turn a corner, you have a resultant force which is towards the center of the circle. A rock falling freely on the moon, it has a resultant force in the downward direction. A train going up a straight hill at constant speed. Yeah, this can be the answer, because constant speed means the forces are balanced in a straight line. So C can be the answer. An aircraft accelerating along a runway in a straight line. If an object is accelerating, its forces are not balanced. It has certain resultant force. So I think C is the best answer. Question number 6. C is the right answer. A satellite is orbiting. A satellite is orbiting the Earth. What is the direction of the force on the satellite causing this circular motion? The force on the satellite will be towards the center of the Earth because it's orbiting around the Earth. So the force will be centripetal force and it will be acting towards the center of the Earth. So towards the center of the Earth, yeah, D is the right choice. 4 objects are situated in places where different gravitational field strengths. Which object has the greatest weight? You see, in this question, the mass is given, the gravitational field strength is given for every situation. So very easily we can find out the weight. The formula for the weight is W equals to mg. So for all these 4 options, I will calculate the weight and then we will decide where we have the greatest weight. He's asking us to find out the greatest weight. I've done this on a paper. Let me show you my work. So WA in the A option, it will be 3 into 10.4. That will be 31.2 Newton. In the B option, 3.5 multiply 9.5 and it will be 33.25 Newton. In the C option, 4 multiply 10.2, it will be 40.8 Newton. And in the D option, 4.5 multiply 9, it will be 40.5 Newton. So where is the greatest weight? That is 40.8. The option is C. The option is C. Let's see. So C will have the greatest weight. Question number 8. C is the right option, sir. A beam of length 40 centimeter is pivoted at one end. The weight of the beam is 4 Newton and acts at a point 20 centimeter from the pivot. A 2 Newton weight hangs 10 centimeter from the pivot. An upward force U is needed to keep the beam horizontal. What is the size of the U? So we want to find out what is the size of this U. So pivot is here. You can see the pivot is here. So these two forces, they are trying to produce clockwise moment, and this force U is trying to produce counterclockwise moment. So according to the principle of moments, we know that the sum of the clockwise moments will be equal to the sum of the anti-clockwise moment. So I have done this on a paper. Let me show you my work. Hopefully it is visible to you. You see the anti-clockwise moment is equals to clockwise moment. This 2 Newton force, the distance from the pivot is 10. This 4 Newton force is distance from the pivot is 20 centimeter. So the anti-clock, these two are the anti-clockwise, these two are the clockwise moments, and that you trying to produce anti-clockwise moment is distance from the pivot is 40 centimeter. So u multiply 40 equals to 2 multiply 10 plus 4 multiply 20. The sum of the clockwise moment and sum of the anti-clockwise moment, they are equal to each other. So 40u will be equals to 100. So u will be equals to 2.5 Newton. I hope that you have understood this numerical. 2.5 Newton. So you can see C is the choice. A car is designed to be stable. To achieve good stability, where is the center of mass of the car? The center of the mass of the car should be lowest as it can be. So it says as low in the car as possible. So D is the choice. Above the front wheels, above the rear wheels, as high in the car as possible, as low in the car as possible. D is the right option. The center of mass should be very low, then the thing will become very stable. A force is applied to a body. Which property of body cannot be changed by the force? One thing which you cannot change by applying force is mass. So A is the option. Its shape you can change by applying force. Its size you can change by applying force. Its velocity you can change by applying force. So A is the option. The mass cannot be changed by applying force. The graph shows the extension of a piece of copper wire as the load on it is increased. So it's an extension load graph. What does the graph shows? That at a certain load, the wire becomes easier to extend. Yes, up till here, the extension and load are directly proportional to each other. But after this point, when the graph turned upward, it became a curve and it turned upward. This means that if you the extension and the load, they are no more directly proportional to each other. And if you put a slightest load further, what will happen? The extension will be quite large. So at a certain load, the wire becomes easier to extend. This is the answer. At a certain load, the wire becomes harder to extend. No, the load and extension are directly proportional to for all loads. No, they are directly proportional up till the point when the graph was a straight line. The load and extension are inversely proportional for all bodies. That's wrong. They are not inversely proportional. The diagram shows a manometer containing mercury that is sealed at one end. What happens to the distance h when the manometer is taken to the top of a mountain? So you see, when you go to the top of a mountain, so what will happen when you go to the top of the mountain? The atmospheric pressure will decrease. When here the atmospheric pressure will decrease, this gap, because this will go up, this the level of the mercury in the limb which is on the atmospheric side, the side which is open to the atmosphere, that will go up. This gap, that will decrease, because when you go on the mountains, you go on the higher altitude. So what happens? The atmospheric pressure decreases. So A looks the best answers. A gas occupies a volume 2 meter cube in a cylinder at a pressure of 240 kilopascal. A piston compresses the gas until the volume is 0.50 cubic meter. The temperature remains constant. What is the new pressure of the gas? The new pressure of the gas, it's very simple. You see, the temperature remain constant. I'm talking about a gas. So I can apply the formula P1 V1 equals to P2 V2. P1 V1 equals to P2 V2. Let me show you my work. I've done this on a paper. So P1 V1 equals to P2 V2. P1 is 240 kilopascal. The V1 is 2 meter cube. The P2 is question, and V2 is 0.50 meter cube. So make the P2 subject of the formula. So it will be 240 multiplied 2 divided by 0.50. And the final answer when you enter these things in your calculator will be 960 kilopascal. 960 kilopascal. 960 kilopascal. It looks the D is the choice. Where is the energy? Where is the energy released by the fusion of hydrogen nuclei to form helium? You see, smaller nucleus of hydrogen, they come close to each other and they join each other and they make a nucleus of helium. Smaller nuclei fused together to make a larger nucleus. We call this fusion, and this is happening on stars and on the sun. In the core of the sun. A crane lifts a load of 6,000 Newton through a vertical distance of 15 meters in 30 seconds. What is the average useful power during this operation? We can find out the power, and formula is very simple: work done divided by time. So work done, if you know the weight and you know the vertical height gained, so work done will be weight multiply vertical height. If you divide that thing with the time, you will get the power. Let me show you my work. Yeah, here we go. So power is equals to weight multiply height divided by time. Weight is 6,000, vertical height gained is 15, divided by time is 30 seconds. So you will get 3,000 watt. So the power will be 3,000 watt. C is the right choice. A javelin has a mass of 0.80 kg. The javelin is released with 250 joules of kinetic energy. What is the speed of this javelin? We know the kinetic energy, we know the mass. So the formula for the kinetic energy is 1 by 2 mv square, and very easily we can find out the speed. We know the kinetic energy and we know the mass. I've done this on a paper. So kinetic energy is equals to 1 by 2 mv square. Kinetic energy is 250. 1 by 2 mass is 0.80 kg. V is question, so make V square on one side, bring it one side. So it will be 250 multiplied 2 divided by 0.80. Answer will be 625. Then take square root on both the sides. So V will be equals to 25 meter per second. 25 meter per second. Here we go. C is the choice. A piston is supported by gas trapped in a cylinder. A weight is put on the piston. The volume of the gas supporting the piston decreases, but the temperature of the gas is unchanged. What happens to the molecules? So the molecules will come close to each other. The volume, the density of the volume per the number of molecules per unit volume will increase. The frequency of the molecules hitting the walls, that will increase. They hit the piston more frequently. Yes, that is right. They move more slowly. No, the temperature has not changed. They have a smaller size. The size of the molecules do not change. They have more kinetic energy because the speed has not changed. That's why the kinetic energy has not changed. So A is the best option. A famous numerical on thermometer. The diagram shows a liquid in glass thermometer at 0 degrees centigrade. The length of the liquid column is 2 centimeter. It means L naught is 2 centimeter. At 100 degrees centigrade, the length of the liquid column is 22 centimeter, which means L100 is 22 centimeter. What is the length of the liquid column at 40 degrees centigrade? His question is when the temperature will be 40, when the temperature will be 40, what will be the length of the mercury? L theta is question. And let me show you my work. It's a famous numerical. You should never forget this. L theta minus L naught divided by L100 minus L naught equals to theta by 100. L theta means the length of the mercury at 40 degrees centigrade. L naught means the length of the mercury when the temperature is 0. L100 means the length of the mercury when the temperature is 100. So L theta minus 2 divided by 22 minus 2 equals to 40 divided by 100. Theta is 40 here. So just do your calculations. L theta minus 2 divided by 20 equals to 40 divided by 100. All the zeros are cancelled with each other. So L theta minus 2 will be equals to 4 multiplied 2. And then this minus 2 will go on the other side. So it will have L theta equals to 8 plus 2 equals to 10 centimeter. A very famous numerical. So the length of the mercury when the temperature will be 40 will be 10 centimeter. So D is the choice. A hot liquid is poured into a beaker. The graph shows how the temperature of the liquid changes as it cools towards room temperature. So we have a hot liquid and it's cooling down. It's a cooling curve. And you know, when the cooling curve becomes flat, it means that the state change is taking place because it was liquid and it's cooling. So at point X, some state change is taking place. So probably the liquid is converting into solid. So the process of solidification is happening, and you know, when the solidification will be happening, the evaporation will continue. So the choice is D. Solidification and evaporation is happening at the point. At this point X, the solidification and the evaporation both are happening. So question number 20, the answer is D. A fixed mass of gas in a syringe at 0 degrees centigrade is heated at constant pressure. Which graph shows the variation of the volume V with the temperature T measured in degrees centigrade? You know, if the temperature is constant, the volume and the temperature, they are directly proportional to each other. So if you increase the temperature of the gas, its volume will also increase. It's very simple. But you know, so you might get confused with these two. This graph is in your book, but this graph, if we draw, this graph passes through the origin 0, 0. When the temperature will be 0, the volume will be 0. If the temperature is in Kelvin, this A graph is only possible if the temperature is in Kelvin. Then when it will be 0 Kelvin, the volume of the gas will also become 0, which is a hypothetical thing. We call this absolute 0. So, but here he has shown degree centigrade. When there is 0 degree centigrade, the volume of the gas will not become 0. So this is the answer. So B is the best option. Yes, with the decrease in the temperature, the volume should also decrease. But at 0 degrees centigrade, the volume of the gas will not be zero. So A cannot be the answer. A can be the answer. The shape can be answered, but if on the x-axis the temperature is in the Kelvin scale, if the temperature is on the x-axis in degrees centigrades, then the B is the best option, sir. Compression and rarefactions are sent out from a loudspeaker cone as it vibrates backwards and forwards. The frequency of vibrations is 50 hertz. A compression is at point P. How much time elapses before the next rarefaction arrives at P? So the time duration between one compression and the next compression is called one time period. But the time between one compression and the next rarefaction, that is half the time period. It is half the time period. The time between one rarefaction and the next rarefaction, that will be one time period. But the time between one rarefaction and the next compression, that is half the time period. The frequency of this wave is given. If you know the frequency, you can easily find out the time period. So the time period will be 1 by f, 1 by 50 hertz. Once you know the time period, just divide it with 2, you will get the time when on this rarefaction another compression will reach. The next compression will come. The time between the rarefaction and the upcoming compression is half the time period. I've done this on a paper. Let me show you my work. So you see the frequency, you know, is 50 hertz. So I can find out the time period. T is equals to 1 by f equals to 1 by 50 equals 0.02 seconds. One time period means if you have one rarefaction, the next rarefaction, the time elapses when a next rarefaction will arrive, that is one time. But the question is not this. The question is now at P we have a rarefaction. So when the next compression will come, how much time has elapsed? So very simple. It's half the time period. So divide the time period with 2. 0.02 divided by 2, that will be 0.01 second. I hope that you have understood. A is the choice. Water waves refracted at a boundary between deep water and shallow water. What is the effect on the frequency, wavelength, and speed of the waves at the boundary? You see, when the water waves from the deep water, they will enter into the shallow water. The frequency will remain unchanged. There is no change in the frequency. The speed will decrease and the wavelength will also decrease. So when the water waves, they enter from deep water into shallow water, the frequency remains the same, wavelength changes, it decreases basically, and the speed will also change. It means it will decrease. So frequency unchanged, wavelength decrease, speed decrease. So I think C is the right choice. Question number 23, C is the right choice. Question number 24. The diagram shows two divergent rays of light from an object O being reflected from a plane mirror. At which position is the image formed? You see, it's very simple. How you locate the image? You see, from the object, this line which is making 90-degree angle with the mirror, prolong it or produce it behind the mirror, and this reflected ray, prolong this or produce this behind the mirror. So where these two rays will intersect, that is there the image will be. There you will be able to see the image. Let me show. I have done this on a paper. You see here. So you can see this the ray which was coming from the object and making 90-degree angle with the mirror, I have prolonged it behind the mirror with the red color. And then this reflected ray from the mirror, I have prolonged it behind the mirror with a green color line. So where they both intersect, there the image will be seen. So the image will be formed on the point B. I hope that you have understood this. The image will be formed on the position B. Three rays of light are incident on the boundary between a glass block and air. The angle of incidence are different. So when the angle of incidence is 20, the light is entering into the air. When the angle of 40, the angle of incidence in the dense medium is 40, the light is still entering into the air. The angle of refraction will be larger than the 40. And when the angle of incidence is 50, the process of total internal reflection has taken place. Instead of light going into the air, the light has bounced back, light has reflected back into the dense medium. This is called total internal reflection. When the total internal reflection happens, the angle of incidence is more than the critical angle. So it means the critical angle, this 50 angle of incidence is more than the critical, and this angle is less than the critical. So the critical angle is between 40 and 50. So look at here. What is the possible critical angle for the light? The critical angle value is more than 40 and less than 50. So clearly a little logic you use and you will know C is the possible critical angle. Because the value of the critical angle should be less than 50, more than 40. Because when the total internal reflection happens, the angle of incidence in the dense medium is more than the critical angle. And when the light is entering into the rare medium, the angle of incidence in the dense medium is less than the critical angle. So it means the critical angle is between 40 and 50. So it can be 45 according to the given options. 25, C is the option, sir. Which statement is correct? Gamma rays have a longer wavelength than the ultraviolet. Let me, if you write that, let me take out the pen. So, pen here. Acha, see, I just want to show you. I want to show you the code word. That is Ronald McDonald is very ugly except Gary. This is the code word which we use. Ronald McDonald is very ugly except Gary. Okay. So radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, gamma rays. Radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, gamma rays. Ronald McDonald is very ugly except Gary. Okay. Now, as you move down, as you move down, as you move down, the frequency will increase and the wavelength will decrease. As you go down in this order, the frequency will increase and the wavelength will decrease. It means red has the highest wavelength, largest wavelength. Gamma has the smallest wavelength. Red has the least frequency and the gamma has the highest frequency. In this order, when you go down, your wavelength decreases and your frequency increases. Now we look at the options which we have. Gamma rays have a longer wavelength than the ultraviolet. Let me check. Gamma rays has a longer wavelength than the ultraviolet. That is wrong. Ultraviolet has longer wavelength. Okay. Now, the next. Let me reduce the size. Infrared waves have a lower frequency than the radio waves. That's wrong. Infrared has more frequency. Microwaves have a longer wavelength than the visible light. That is true. X-rays have a higher speed in the air than the visible light, though that's wrong. The speed of the transverse waves or electromagnetic waves is same in the air. They all travel with the same speed in the air. So I think question number 26, C is the best option, sir. C is the best option. Question number 26. Which row applies to a short-sighted eye viewing a distant object? You know, whenever a person has short-sighted eye, it means that he is able to see the near objects, but he is not able to see the far objects. The reason is that his lens is bending the light rays too much. So what the because the lens is bending them too much. So what happens? The light rays, they are focused before the retina. So in front of the retina, the light rays should be focused on the retina. But what happens when a person is short-sighted? The light rays are focused in front of the retina, and this can be corrected by using a diverging lens. So D is the best option, sir. Question number 27, D is the best option. Which statement about the speed of sound is correct? The sound moves fastest in the solid and slowest in the gas. And in vacuum, it cannot travel. So sound travels fastest in the solid. So D is the choice. In vacuum, it cannot travel. The sound travels fastest in gases. That's wrong. Sound travels faster in liquid. That's wrong. The sound travels fastest in solids. A piece of electric equipment is sensitive to magnetic fields and is screened from them. To do this, it is enclosed in a box. Which material should be used to make the box? You know, for magnetic screening, the box is made of iron. It do not let the magnetic lines come in. So very simple. It's a fact and a very simple question. So question number 29, B is the right choice. A piece of wire has a resistance of 16 ohm. Another wire made from the same metal has 4 times the length and twice the cross-sectional area. What is the resistance of the wire? I've done this on a paper. Let me show you my work. So here we go. Because you know the resistance is R is equal to rho L by A, where rho is called resistivity, which depends upon the nature of the material. Resistivity, if both the wires are made of the same material, so their resistivity will be same. So rho 1 will be equal to rho 2. So formula for the rho is R1 A1 by L1. So R1 value is 16 ohm, A1 suppose it's A, and the L1 is L. R2 we want to find out. A2, the cross-sectional area is double the cross-sectional area in the first case, and the L2, that's 4 times the length. So when I will make the R2 alone, A and A cancelled on both sides, L and LO cancelled on both sides. So you will have 16 multiply 4 divided by 2. The answer will be 32 ohm. So the R2 value will be 32 ohm. 32 ohm. I hope that you have understood this numerical. And let me go to the 32 ohm. So B is the choice. B is the right choice. A battery of EMF is connected in the circuit containing 3 resistors. The readings of the 2 ammeters and the voltmeters are shown. So this is measuring the current coming from the battery. This measures how much the current is flowing to this branch and how much current is flowing to this branch. Okay, so let me reduce the size first so you can see the whole question. Okay, the readings of the 2 ammeters and a voltmeter are shown. Which readings are shown on the ammeter X and the voltmeter Y? You see, from the battery, I naught current came, and here the current will be divided. I1 current passing from the upper branch. So through this lower branch, the amount of current will be I naught minus I1. I naught minus I1 will be the reading on the ammeter X. Okay, the battery is providing the voltage E. Here the voltage drop is V naught. So here the voltage drop on each of the branch will be equals to E minus V naught. So clearly A is the right option, sir. A is the right option. A is the right option. 1 kilowatt hour of energy costs $0.24. How much does it cost to run a 2 kilowatt heater for 3 hours? We want to find out the cost. So very simple. The formula is power multiply time multiply price of the 1 unit, and the power must be taken in kilowatts and the time must be taken in hours. You just put the values in that formula, and you will be able to find out the cost. I've done this on a paper. You see the cost power is equals to 2 kilowatts, the time is 3 hours, and the price of 1 unit is 0.24. Just multiply it. $1.44. $1.44. Let's check. 1.44. So D is the choice. Question number 32. D is the choice. This one is a tricky one. A single electrical component is placed inside a box. 2 leads from the component emerge from the box. These leads are connected in series to an open switch S, a battery, and an ammeter. The switch S is closed and the ammeter registers a current. For a few minutes, the size of the current gradually increases. For a few minutes, the size of the current gradually increases. So when you close the switch, the current started gradually increasing. What is the component inside the box? A capacitor. If you put a capacitor, the current will gradually decrease. At the start, the current will be far larger, but gradually it will decrease. A filament lamp, the filament lamp also, the gradually the current will decrease. A fixed resistor, if you have put a fixed resistor, the current will not change at all. A thermistor, oh yeah, if you put a thermistor here, if you put a thermistor here, what will happen? The this When the current will flow through the thermistor, heat will be produced, and when the temperature of the thermistor will rise, its resistance will decrease. So the current coming from the battery will increase. So the correct answer is, oh my god, I by mistake highlighted the whole thing. The correct answer is D. D is the right answer, a thermistor. Because thermistor, when you will the current will flow through the thermistor. Obviously, when the current flows, the heat is produced, and when the heat is produced, the temperature will rise, and the resistance of the thermistor, when the temperature rises, will decrease, and it means when the resistance will decrease, the current coming from the battery will increase, so the reading will gradually increase. So D is the choice, sir. A beam of alpha particles are positive, enters the magnetic field between the poles of a magnet. So it's here we have north magnetic field, which the direction of the magnetic field is from north to south. Alpha particles which are positively charged are going from left to right. Which direction is the magnetic force on the beam? You see, you know the left hand rule. The left hand rule. You take your left hand, stretch the fingers of the left hand. This is the index finger. This is your thumb. This is the middle finger. They should be perpendicular to each other. They should be stretched in such a way that they are perpendicular to each other. So FMC, thumb is F, for index finger is M, and this middle finger is C. FMC. So the current is going towards left. The magnetic field is downward. The current is going towards the left. The magnetic field is from north to south downward. My thumb is pointing into the screen. My thumb is pointing into the screen. So it means that the alpha particles will be experiencing a force whose direction will be into the page. I got this direction by applying the left hand rule. Hope you have understood. I can show you once more. This is magnetic field. The magnetic field is downward. The current is going to the right, from left to right. My thumb is pointing into the screen. So it means the force will be into the page. So B is the right choice, sir. A magnet is moved into the coil of wire as shown. There is a small reading on the sensitive ammeter, which change increases the size of the reading. The size of the reading on the ammeter can be increased. You use a stronger magnet. The turns of the coil per unit length, they should be increased. Or you move the magnet faster. Moving the opposite pole into the coil, no. Pulling the magnet out of the coil, no. Pushing the magnet in faster, yes. This is the answer. Unwinding some of the turns of the wire, that's wrong. So how the reading on the ammeter can increase? By pushing the magnet faster. If you move the magnet faster, the current produced will be larger. The EMF produced will be larger. So C is the choice. A tricky question on your screen. An ideal transformer has a primary voltage 600 volt and a secondary voltage 240 volt. The secondary coil is attached to a resistor of 120 ohm. What is the power dissipated in the resistor? What is the power dissipated here? And the current in the primary coil. How much is the current in the primary? These are the two questions. I've done this on a paper. Let me show you real quickly that how we have done this. Okay. Now you see question number 36. V is equals to IR, and we are talking about the secondary coil. We know the voltage of the secondary coil is 240 and the resistance in the secondary side is 120. So I is equals to V divided by R. So 240 divided by 120. So the answer is 2 ampere. It means that the current in the secondary is 2 ampere. Then you know famous formula Vp but divided by Vs is equals to Is divided by Ip. So the Vp is 600, the Vs is 240, Is is equals to 2 amperes, Ip is question. So Ip will be equals to 2 multiply 240 divided by 600, it will be 0.80 ampere. So the current in the primary will be 0.8 ampere. Then his question is what is the power dissipation in the secondary? The power dissipation can be found by the formula I square R. So secondary I square R. So 2 square multiply 124, 80 watts. So the current in the primary is 0.8 ampere and the power dissipation in the secondary is 480 watt. The power is 480 and 0.80. C is the choice. A very little difficult question. This question is on color coding. The resistor is given and the colors, the first band has yellow color, the second band is violet and the third band is orange. You know the first band and the second band, we use their digits, and the third band tell you that how much is the 10 raised to power. How much is 10 raised to power? I will show you. A resistor is marked with three colored bands, yellow, violet, orange. Using the key provided, what is the resistance of the resistor? So yellow means 4, violet means 7, and orange means 5. Let me show you my work. So I will write the first two colors, you take their digits, you multiply, and the third color you take it 10 raised to power. Orange is 3, so I will take 10 raised to power 3. So 47 multiply 10 raised to power 3 ohm. So this is 47,000 ohm. So I hope you have understood this, you have studied this already. 47 times, so C is the right choice. Question number 37. C is the right choice. Question number 38 is on your screen. The diagram shows part of a cathode ray oscilloscope. Which particles are emitted by the cathode? When you heat the cathode, the electrons come out of the cathode into the air, and we call this process thermonic emission. We call it thermonic emission. The electrons are given out. So question number 38, A is the right choice. Which row gives the range and electrical charge of an alpha particle? You know the alpha particles, they are like the nucleus of helium. They have positive charge and their penetration power is very low. In air, they can only travel few centimeters. So alpha particles, the charge is positive and the penetration power in the air is just few centimeters. So I think B is the best option. Carbon 14 represents a nuclide of the element carbon and nitrogen 14 a nuclide of the nitrogen. How does a neutral atom of carbon 14 How does a neutral atom of carbon 14 differs from a neutral atom of carbon 16? I've done this on a paper. Let me show you my work. So you can see the proton numbers in the carbon are 6, the proton numbers in the nitrogen are 7, the neutrons in the carbon are 8, and the neutrons in the nitrogen are 7, and electrons are 6 in the carbon, and in the nitrogen there are 7. So let's see what happens. The nitrogen atom has one electron less than the carbon atom. Is this right? The the nitrogen atom has one electron less than the carbon atom. No. The nitrogen atom has one neutron more than the carbon atom. That's wrong. The nitrogen atom has one proton less than the carbon atom. That's wrong. The nitrogen atom has one proton more than the carbon atom. Yes. Nitrogen has 7 protons, whereas the carbon has 6 protons. So the nitrogen has one more proton as compared to the uh, carbon. So this was question number. I think this was question number 40, and this is the last question. So, my dear students, we have reached the end of this paper. So today we have done, which paper we have done. Today we have done May June 2014 1 paper, and I hope that I have tried my best to explain you the concepts, and I have done all the numericals, and so that it becomes very easy for you to understand that how this works, and how the correct options we are getting. So hopefully this video is helpful to you. If these videos are helpful to you, particularly this video, if this is helpful to you, kindly don't forget to subscribe to my channel and also press the bell icon. And I will also request you to recommend to your friends who are in O levels and studying physics and preparing for the Cambridge exam. Kindly recommend these videos to them also, because when by subscribing you will support me, and I will get energy, and I will work harder and harder. I will work more and more. So I hope that everything is and these videos are making life a little easier for you. So thank you very much, everybody. Have a good day, and God bless you all.